Hey guys, this is Jehu Ryder, and it's November 29th, 2013. Let me apologize in advance. I have been battling a cold for the past week, and I thought I was getting over it, and I think it's trying to reassert itself. So I want to apologize in advance, but bear with me. We will get through this. Um, I just wanted to do a quick update on Ison, and then I want to talk a little bit more about these SDO cameras because I'm really perplexed, and I hope someone has an answer. I'm hoping somebody will comment and provide a logical answer on exactly what's going on with these SDO cameras in relation to ISON not showing up on them uh, during the perihelion for ISON. But before I get to that, obviously I'm sure you guys know by now that ISON did make perihelion, and it did survive perihelion. Now, is it intact? How much of it's intact? I don't know. I don't think anyone knows. There's some speculation, obviously floating around. And different parts of the community are speculating that there's been some high fragmentation, little fragmentation, things like that. It does appear from what I've seen, it does look like we may have lost a bit of the comet. I could be wrong on that, but it does kind of look like that. But let me just show you the LASCO C2 camera, and I'm doing this just so you guys can see that it did actually re-emerge. You know, NASA all day yesterday was saying that it didn't make perihelion, but it did. So, and even after we were getting information in or images back in from LASCO C2 and the stereo head and behind cameras, they were still saying it didn't make perihelion, so that it didn't survive. So it was a little surprising, but you know. But here's just a quick vid. You can see that there's ISON approaching, and there it is re-emerging. You can notice the timestamps down here as it progresses. So it certainly did make perihelion, and it certainly did survive. And I will show you some still images of this as well. This image right here, I believe this is from stereo ahead that I'm fixing to bring up. Let's see when it decides to pop up here. There you go. Yep, that's stereo ahead. Notice the timestamp, and here's ISON. Okay. Also, we were able to pick it up on the LASCO C2 camera, and this one isn't time-stamped, but it was at 20:03 UTC yesterday, November 28th. This is ISON re-emerging. I mean, we can see it as clear as day that it did so. I was trying to increase it. There we go. But you know, here's ISON right here. And there it is. It's re-emerging. So, and it does appear to be pretty much on its projected path, or in the predicted path. So that's that's good too. We'll be able to get more information about this as the days go on and ISON moves further away from the sun. We should be able to get a better idea of what we're looking at. But the location of ISON currently, or it's about right there. Let me see if I can get this centered for you. This is about where ISON is right now in this area. So again, the further it can move away from the sun, the better idea we're going to get of how intact ISON may be. But just as on a fun note, you know, the largest sun diver on record that survived perihelion was Comet Lovejoy back in 2011. Now remember, Comet Lovejoy was 200 to 600 meters wide. So if you calculate it at that highest estimate, that would be about 1,600 feet. And that was the largest on record that was a sun diver that survived perihelion. Well, that's not the case anymore because now we have ISON. And according to NASA, ISON was about 2.4 to 3 miles wide before it was making its final approaches, or its a final approach towards the sun to attempt perihelion. So ISON will be officially taking the place of Lovejoy as being the largest sun diver to survive perihelion. So that's really cool. Just kind of throw that out there in case you guys didn't know that. But let me touch on these SDO cameras. I had posted a video yesterday evening about these SDO cameras that Ison was missing from view of the SDO cameras on all of them. It didn't matter what stage it was. It wasn't in the approach, it wasn't in the perihelion, and it didn't show up in the departure. And so when I went back and I was looking at the frames, and it's about 300 frames per camera, and it's about an hour time lapse or so, somewhere around there. And it just none of them had Ison on it. And I just kind of want to show you what I'm talking about here, and I also want to discuss what exactly the SDO cameras see. And I'm going to kind of do it somewhat in layman's terms so we can all kind of be on the same page. But you know, the SDO cameras, they make up essentially 4 telescopes, and they have their own light feeds. So they're able to pick up a particular temperature. Each individual camera is. And what's really interesting about this is that there was 4 cameras. There was the 193, the 171, the 211, and the 131 that was repositioned to get the 3 stages of Ison. And none of these cameras picked it up, but they were picking up things. It's not like, you know, there was nothing coming into view. The timestamp on all of these cameras seemed to be fairly consistent with the stereo ahead and behind cameras, along with the Secchi cameras. So in the LASCO C2 and C3 cameras, they seem to be fairly in sync with them as far as, you know, if you saw the image of Ison on LASCO C2 and you used the timestamp to go and take a look at one of the SDO cameras, you should have been able to see it, but you couldn't. And that was for all of them. It was rather odd. But let me just point something out here. This is the 193 camera that's fixing to pop up on the screen here, and this was during the approach. Now, this one doesn't have the sun in it, but I just want to talk about a couple of things here. Notice the timestamp, and there were little transient objects that were coming through at various times in these frames. Here's one right here, you know, and you can see it's kind of hard to see the length, but the length is in this area right here. Now, obviously, this is not a comet. I'm going to show you what we should have been seeing in view, but I'm just showing this to show that there were some little transient objects coming through, so the cameras were picking stuff up. Same thing with the perihelion. This is the 171 camera that was positioned to pick up the perihelion, and you know, again, little transient objects. There's one right there. Notice the timestamp. So these are around the time that we should have been seeing the comet, but we weren't getting anything. Now, during the perihelion stage, when the cameras were repositioned for that, I saw several objects, over a dozen little transient objects that the cameras were picking up, and you know, things like that. The 131 camera was picking things up. Again, there was over a dozen. Didn't see too much during the approach and the departure. I think a lot of this. Here's a really good one right here. This little guy right here that was coming through in view of the camera during the time that it should have been picking up Ison. But you know, I think during that perihelion stage, just because where it's positioned and the location of where the sun was, that area apparently was very active for, you know, stuff just kind of traveling in view of those cameras there. But I wanted to bring that up to say this. You know, one of the more interesting things about the SDO cameras is that they're designed to pick up any material that has oxides in them, and in layman terms, that means essentially if there's something that comes in view of that camera that has oxygen in it, it should be able to pick it up. And now we know Ison had oxygen in it because Ison was a comet. Well, comets are nothing but ice. Well, ice has oxygen. So where was Ison in these pictures? Where was Ison on the SDO cameras? Very perplexed, very frustrated with that. You know, I don't have an explanation for it. I don't know what it is. I'm hoping that I'm just not understanding this. and that someone might have a logical explanation for this. And if so, hey, please comment on the video. Let me know. Let's have a discussion about it. I know that this has been questioned to NASA already. There's been inquiries sent in, and NASA is not addressing these SDO cameras at all. Now, there's been a lack of information provided by NASA on, on more than one occasion when it comes to Ison, and that for whatever reason they're being very conservative about the data that they're providing with this and the numbers that they're giving. But I don't know about the SDO cameras, but I think it's important to take note about the SDO cameras that they weren't picking it up. If anything, something failed here along the way, whether it was the people, the cameras, I don't know, but something failed somewhere. There's no reason why Ison should not have come into view of these cameras, or have been picked up, I should say, of these cameras. So I'm not really sure what's going on with that, but I just wanted to touch on that a little bit more and just really bring to home the importance of, hey, what's going on here with these SDO cameras. But anyway, exciting. We should be having a pretty good view in the northern hemisphere in December, or beginning in December for several weeks, where we should be able to view Ison with the naked eye. Now, I don't know what the magnitude, well, the magnitude's pretty low right now for Ison, but hopefully as it gets further from the sun, it's, it's kind of recharging. Hopefully we're going to get a good view and we're going to be able to see it, in broad daylight. That'd be awesome. They were expecting that Ison would be anywhere from 10 to 15 times brighter than the moon. I'm not sure if that's going to happen or not, but nonetheless, the northern hemisphere is going to have a treat beginning in December, as long as Ison can remain intact and just go on its merry way and let us observe it a bit more. So we should start being able to see it with the naked eye. But anyway, that's pretty much it. Big comet. It was a glorious comet. Don't know the size. Again, it's NASA put it at about 2.4 to 3 miles wide when it was making its approach. I don't know what the size of it is now. I mean, heck, we're not even sure what the size was really before. There's been some speculation that it could have been 4 times the size of what NASA put it at. I don't know if I would agree with that, but based off of what I was seeing and observing, I would feel comfortable with saying that it could have been 6 or 7 miles, possibly 8. McNaught was one of the biggest comets on the comparison between 2P Encke or Comet Encke in comparison with or in relation to Ison. Again, you had NASA say that Ison was 2.4 to 3 miles wide, and we were seeing on, I believe it was stereo A ahead, if I'm not mistaken, where both Encke and Ison came in view of the camera on the 21st November. Encke was on camera for 2 or 3 days prior to that, in view of stereo A ahead, and then Ison came in on the 21st November. We were able to get a good comparison, and it was very odd because Ison looked very, very big compared to Encke, much, much larger. And there was some speculation about, well, maybe that's because Ison was closer to the camera, but Ison was not closer to the camera. Encke was closer to the camera, and it was closer to the camera by about 25 million miles. So Encke should have looked larger than Ison, but it didn't. So that put a lot of things into perspective, and I had an idea in my mind that Ison was larger than what NASA was saying, but even when I saw these images and I was able to verify that the position, the position of both Encke and Ison in relation to this camera and Earth, or I'm sorry, the Sun, it was mind-boggling. Ison is much, much bigger than what we thought and what we were told it was. Now, how much bigger, don't know. I'm not comfortable in saying that it's 12 miles. I know some people are putting it at 12 miles. I'm not comfortable in saying that. I don't think it's that. I would say that it could be anywhere from 6 to 8 miles. I feel very comfortable with saying that. Again, that would mean that it would be rivaling Comet McNaught, because NASA put it between 6 and 12 miles. You had Comet Halley, or Halley's Comet. Well, actually, I'm sorry, it's the traditional way of pronouncing that is Halley. And that one was somewhere about 9 to 10 miles wide, somewhere around there. So Ison was a big boy. He was a big guy. How big was he? We don't know, but he was a big guy. And it's certainly just huge to be a sun diver and to be able to survive perihelion. So hopefully we'll get some good information over the next several days regarding Ison. So, anyway, but that's about it. Love you guys. God bless you guys. Take care and keep your eyes on the skies.